Hi, this is Mrs. Jones, and in this session we're going to look at calculating exothermic reactions. If you haven't already done so, make sure you watch my introduction video to exothermic and endothermic reactions so you understand the meanings of exo and endothermics. But in this session we're going to look at a typical WJEC question, and this comes from a foundation paper. So it says ammonia is manufactured from hydrogen and nitrogen in the Haber process. The equation shows the bonds which are broken and the bonds which are formed during the manufacture of ammonia. So you have to remember that each reaction is split into two. Okay, and so this is your reactant side and this is your product side. On the reaction side, all of these bonds need to break. Okay, and this one here needs to break so that it can rearrange into a new product. Okay, now that actually takes energy. So this part of the reaction is actually endothermic. Okay, so bonds are broken on the reactant side. So anything before the arrow. On the flip side of that, on the product side, okay, you're going to have products that are being formed and bonds are going to be formed, and during that process energy is released. Okay, so reactants bonds are broken, products bonds are formed. Okay, and then underneath it says relevant bond energies are shown in the table. So you have a list here of the bonds and how much energy it takes to break or form each of those bonds. So if we look at a nitrogen triple bond, nitrogen to nitrogen triple bond, it takes 945 kilojoules of energy. Okay, we've got hydrogen to hydrogen. This is a single bond and that is 436 kilojoules of energy. So the first part of the question says calculate the total energy needed to break all of the bonds in the hydrogen molecules and the nitrogen molecules. So because it's talking about bond breaking and it's talking about hydrogen and nitrogen, it's the reactant side that we're interested in. So what you would do is you would write down what bond you're looking at, then you go down to the table. So you've got hydrogen to hydrogen is 436 kilojoules to either break or make that bond. We're looking at breaking this one, and we've got 1, 2, 3 of them, so we times that by 3 and that gives us 1308. Okay, then we've got a nitrogen to nitrogen triple bond, which is 945. Now we've only got one of them, so we don't need to times that by anything. So you add this number and this number together and that gives you a total of 2253 kilojoules of energy. So I'm just going to make a note of that over here because I haven't got enough space to keep it all on the screen. So I'm just going to put 2. So part 1, our answer was 2253 kilojoules of energy. Okay, and then part 2 says calculate the total energy released when all of the ammonia molecules are formed. So again, what it's talking about here are the products. Okay, and all of the energy released when these bonds are actually formed. So what bonds are involved in the products? So we've got nitrogen to hydrogen, which is if we go down to our table, so nitrogen, hydrogen, okay, and then go to the bond energy is 391. Now we need to figure out how many of these bonds are there. So it doesn't matter which way around they are, whether they're nitrogen to hydrogen or hydrogen to nitrogen, it's still the same bond. It's one nitrogen atom bonded to a hydrogen atom. Okay, so we've got 1, 2, 3, 4, 5, 6. So we need to times this by 6, which gives us a total, oh dear me, which gives us a total of 2, 3, 4, 6 kilojoules. Okay, so I'm just going to pop that here Just going to make a note of that here. So we've got 2, 3, 4, 6 kilojoules. Okay. Then the last part of this question says use your answers from part 1 and part 2 to calculate the overall energy change. So what it means by overall energy change is, remember I said in the beginning that any reaction, there's two parts to it. There's an endothermic part where the energy from the surroundings is absorbed so that you can use that energy to break all of the bonds. So those atoms then can be rearranged to form a new product, and when the bonds are formed, that energy then is released. What that means is we want to know overall whether it's an endo or exothermic reaction. So part 1, we've got 2.253 kilojoules, and that was where the energy was absorbed. Okay, and you could say that that is endothermic. Okay, and then part 2, okay, where all the products are formed and all the bonds are formed and the energy is released, which is 2.346 kilojoules, and that would be exothermic. So we have these two numbers. Now we always take the products away from the reactants. So it would be 2.253 take away 2.346, and then that would give us minus 93 kilojoules. Now, so that means the overall energy change is minus 93 kilojoules. And because it's a minus number, it's exothermic. And you can, if you just look at the numbers, you can see that the number of the amount of energy released when the bonds were formed is bigger than the amount of energy absorbed when the bonds were broken. Okay, so you can see that actually more energy was released when the bonds were formed on this side. Okay, but we need to look at how much was absorbed and how much was given out. And remember, you always do reactant energy, take away product energy, and that will give you the overall energy change. Okay, don't get thrown by the fact that 90% of the time, I'd say probably 99% of the time, this number is going to be smaller and you will end up with a minus number. Okay, guys, if you do need any further help on this, don't forget to contact me on Google Classroom.